I'm creating this video in case we have a snow day. I don't want you to get behind, and I want you to be able to use this technology to move ahead. Hopefully you have already completed you've completed the warm-up on page 30 and done your best to do the problems on page 31 so that you can kind of fill in the gaps. You can see that our objective is to apply the average value theorem. That's what we're going to be learning in just a few minutes. But first, we're going to start with a warm-up of the fundamental theorem of calculus just to kind of keep that fresh in your mind. I'm going to find the definite integral by doing a rewrite, and I'm going to rewrite this as t to the 2/3 power plus t to the 1/2 power dt. I'm going to integrate term by term, and so I get t to the 5/3 multiplied by 3/5 plus t to the 3/2 multiplied by 2/3 from 0 to 1. And so when I substitute 1, I'll get 3/5 plus 2/3, and when I substitute 0, I'll get 0 plus 0. So my common denominator will be 15, and that will give me 9/15 plus 10/15 for a total of 19/15. Okay, hopefully you find that to be an easy problem. Problem number 2 is an absolute value problem. When you see absolute value, you should start thinking about graphing it. This is shifted to the left 1 unit. Actually, let's move that down just a little bit. Oh, bigger eraser. Alright. So let's move it down a little bit, and it's shifted to the left 1 unit, which is the vertex. The vertex is the key to the problem. Now I'm going to substitute -3 in place of x. -3 plus 1 is -2, and the absolute value of -2 is +2. So there's -3. We just found out that this is 2. This distance is 2. 2 times 2 is 4. Half of 4 is 2. I just was finding the area using my triangle formula. I'm going to substitute 5. 5 plus 1 is 6. The absolute value of 6 is 6. 1, 2, 3, 4, 5. And we said that that goes up to 6. Now be careful, this is not 5 units. This, from starting at the vertex, is 6 units. 6 times 6 is 36. Half of 36 is 18 using area of triangle formula. 18 plus 2 is an easy 20. Now the other way to do that problem, if you want to, is to separate the integral, start at -3 and go to the vertex of -1 of the negative side of the absolute value function, plus start at the vertex -1, stop at 5 of the positive side of the absolute value. Now if you're going to do that, you're going to have to distribute the negative and make this -x minus 1. So you would have -x squared over 2 minus x, and that would be evaluated from -3 to -1, plus x squared over 2 plus x evaluated from -1 to 5. And you would just do your arithmetic and clean it up, and that's how you would do that particular problem. Alright, let's move on to the lesson. This is kind of a cool lesson. Some things I want you to consider. Let's take a look at the problem. We have 2 problems here, and in the first problem we're given a position function. Now this is very important to understand what are we starting with, because if you look at the question in part A, they're asking us to accomplish exactly the same thing in both cases. Find average velocity. And over here I'm finding average velocity using the velocity function. Now if you have not noticed this yet, I want you to notice that the derivative of this position function is this velocity function. So these 2 functions are definitely related to each other, because that is the velocity function for this particular position function. Okay, so they are definitely related. Now again, we're trying to find average velocity, and average velocity is average velocity. It doesn't matter what function you have. There's only one way to define average velocity, and it's a middle school idea. Average velocity is always change in position over change in time, no matter what. So regardless of which function I have, average velocity is change in position over change in time. Now, since average velocity is change in position over change in time, which is a good old-fashioned slope, then that makes it easy in problem number 1 because what do I have? I already have a position function. So change in position in this case would be s of 4 minus s of 1. That's my change of position over change in time, which is 4 minus 1. S of 4 is 21, and S of 1 is 0 over 4 minus 1. And when I clean that up, that gives me 21 over 3, which is 7 feet per second. So that particle, or whatever's happening here, was traveling at an average velocity of 7 feet per second. And that was really, really easy to do when you were given a position function. It involved no calculus whatsoever. It's a basic middle school problem. Now, number 2, we're going to we're going to have to definitely think about some calculus here. We're trying to accomplish exactly the same thing over exactly the same interval, and as we said, average velocity is change in position over change in time. Well, I don't have a position function, I have a velocity function. What do I need? A position function. What do I have? Velocity. I have velocity, I need position. I think you're starting to figure it out. If we have velocity, we can go back to position by doing what? Yes, finding the antiderivative. So if I want to get the change in position, then I'm going to integrate the velocity, and that will take me back to position. Now, all that will do, though, is it'll take me back to position. It doesn't give me the change in time. So in this case, since we want the change in position, we're going to go a definite interval from 1 to 4. When I find the antiderivative, I would evaluate that from 1 to 4. So see, I'm accomplishing the same thing, but I have to add one extra step in. I have to go and get my own position function because in problem 2 it wasn't given. Now I have change in position, that's a good thing, but I don't have the change in time. So I have to divide by the time. So change in time, that's easy. 4 minus 1 is 3, so I get 1/3 out front. Now that's the same thing as dividing by 3. See, here's my dividing over on the left-hand side. Here's my dividing by the 3. Doing the same thing over here, just with an integral. All right, so what's the big deal here? What's going on here? What did I start with? I started with velocity. And if I wanted average velocity, I had to go back and get his position function so I could do my slope. So I'm trying, the words are average of velocity, which says go backwards. When you're trying to find the average of a function, go backwards. So in this case, I would have 1/3, there's my change in time, the integral of 1 to 4 of 3t squared minus 6t plus 1 dt, which would give me 1/3 of, now watch this, t cubed minus 3t squared plus t from 1 to 4. Now you may be thinking, oh, wait a minute, what happened to my plus 1? Remember, that's the value of c, and it really doesn't matter because when we evaluate this, even if I had a plus 1 in there, it would subtract out when I find f of 4 minus f of 1. Now, if you do the arithmetic of this, you will get 21 minus 0 times 1/3, which is 1/3 of 21, which is 7 feet per second. Now, you may not be horribly amazed by this, but it is a pretty amazing process because we're able to find the average of velocity by using calculus. So what's the big deal? Well, on a quiz, on a test, on an AP test, they will not even give us a position function. They'll give us velocity, and they'll say find the average velocity, and expect me or expect you or expect us to know how to know what to do with that. Now let's look at question B. Question B goes back to a while back. they're asking us find the value C guaranteed by the mean value theorem. Because mean value and average value are very connected to one another, and I'm going to show you the connection in just a minute. So let's take a look at we're trying to find the mean value theorem of this function right up here. Mean value theorem says that somewhere the average rate of change is equal to the instant rate of change. So I'm going to find the average rate of change. The average rate of change, remember slope, this derivative. Okay, so the average rate of change we already know is s of 4, we already did that part, minus s of 1 over 3, which is 7. The instant rate of change would be the derivative, which is 3t squared minus 6t plus 1. So 3t squared minus 6t plus 1. This is quadratic, so I'm going to set it equal to 0, and I get 0 equal to 3t squared minus 6t minus 6, which is t squared. I'm dividing everything by 3. 2t minus 2. Okay, now this function is not factorable, so I went to my calculator, or the quadratic formula, and there were 2 times at which my instant rate was equal to my average rate. 1.184 is not on the interval of 1 to 4, so the mean value, now think back to the mean value theorem. Remember, it was Thanksgiving, and we were going on a trip to Grandma's house. It was on the exam. This is the time at which my car was traveling the 7 feet per second. So in other words, it's kind of an x value, y value scenario. 1.816 is the mean value. That is the x value. That's the time at which this happened. The average value is how fast I was actually going. So average value is a y value, and this was my actual velocity. So mean value, when did it happen? Average value, what was it? Mean value, this is the time that my instant velocity was equal to my average velocity, and my average velocity was 7 feet per second. Now, if I was going to do the same thing with letter B, I was going to find the guaranteed by the mean value theorem. I would do the same thing. I would take my instant rate of change, which was already given as velocity. That was my instant rate of change. And I would set it equal to the average rate of change, which I calculated already. So in other words, it's exactly the same problem. What I want you to see is that mean value is an x, average value is a y. Mean value is when it happened, average value is what happened. So let's summarize this. What the heck are we trying to say here? To find the average value of a function, average of a function. So we're trying to find the average of f of x. Well, an average, when you're averaging grades, you have to divide. And so that's going to be 1 over b minus a, the integral from a to b of f of x dx. And that's how you're always going to find. So we're starting with the function of f of x. We find the antiderivative to go backwards. We have a given interval, a time interval from a to b, and we have to divide by that time, and so that's the 1 over b minus a. Now that's the same thing as the integral of a to b of f of x. So that would be accumulating if f of x was a velocity function. Going from a to b of f of x would be accumulating position or displacement, and then we could divide by the time of b minus a. I just think I like it better by pulling the 1 over b minus a out front, but you could write it this way if you wanted to. So here's my averaging. See, I'm dividing by b minus a, so that is the part where I'm averaging. All right, let's see how this works. Find the average value, so we're finding the average of f. So it's telling me average of f I need to integrate. So when I find the average of f from 0 to 5, I'm going to have 1 over b minus a, the integral from a to b of f of x dx. So that would give me 1 over 5 minus 0 times the integral of 0 to 5 of 3x squared minus 2x dx, which would give me 1/5 of 3x cubed over 3, which would be x cubed, minus 2x squared over 2, which would be x squared, from 0 to 5, which would give me 1/5 of 125 minus 25 minus 0 minus 0, which will give me 1/5 of 1/20th, which would give me 24. Now there are no units in this problem because it didn't say what f of x was representing. So the average value, it's an average y value. The average y value is 24. Now in this case they didn't ask me to find the mean value or the time or the x value which that occurs. And you'll notice that this example is not even on your paper, so don't worry about that. So it's a real simple process. You're averaging, and that's why we have that's why we're dividing by. That's why we have the 1/5 out front, because that's what makes it an average. Remember, when you're averaging grades, you divide by the total number, and there's the averaging process in this problem. What I'd like for you to do, and nope, no test on Tuesday. This is old. This is before all the snow occurred. Page 328. 57 to 63 and 67 to 62, and practice the average value theorem. I think I actually have another video posted on my Edline page from someone else on the average value theorem if you need more, and certainly you can look at your textbook and come in and ask me questions, but I hope you're able to do this using the notes that we just did.